Click the bell icon to get latest videos from Ekeeda.
Hello students. So inverse hyperbolic function is a very important part of complex number, and now we are going to solve a numerical which is based on inverse hyperbolic function with the help of different identities of inverse hyperbolic function. So here it is given that hyperbolic cos inverse of A plus hyperbolic cos inverse of B is equal to hyperbolic cos inverse of X, and we have to prove this result. Now if you observe this result, then here in the answer we want A under root B square minus 1 plus B under root A square minus 1 equal to under root X square minus 1. So it means in the given term we have hyperbolic cos inverse, but in the result we do not have hyperbolic cos inverse term. So the trick is how to get that value. So for that we'll do few assumptions. So I'll assume the value of hyperbolic cos inverse of A as alpha, this as beta, and hyperbolic cos inverse of X as gamma. So now if I substitute these three values in the given result, so we'll get alpha plus beta equal to gamma. Now to prove this result, what we'll do is we'll take hyperbolic sign on both sides of this result. So by doing that, here we'll get hyperbolic sign of alpha plus beta equal to hyperbolic sign of gamma. Now you must be thinking why I've taken this hyperbolic sign, because if I apply the formula of hyperbolic sign of alpha plus beta here, and if I expand it, then I will get two terms, and then if I do the arrangement or if I do few substitutions from here, then I can get this result. Now for that what we have to do is from here we have to derive few more values. So like if I substitute hyperbolic cos inverse on the right hand side, here I'll get hyperbolic cos of alpha and the value will be A. So here I'll say A equal to hyperbolic cos of alpha. Similarly here we'll get B as hyperbolic cos of beta and X as hyperbolic cos of gamma. Now these values are helpful while solving this identity. So by expanding this using the formula of hyperbolic sign, we'll get hyperbolic sin of alpha into hyperbolic cos of beta plus hyperbolic cos of alpha into hyperbolic sin of beta equal to hyperbolic sin of gamma. Now guys, here for hyperbolic cos of beta we have value as B, so I can substitute that value B over here. For hyperbolic cos of alpha we have value as A, I can put it here. But for hyperbolic sin of alpha we do not have any value, and that is why we'll convert this hyperbolic sin of alpha in terms of hyperbolic cos of alpha, because for that we have the value. Now how to do that? So we know the identity of hyperbolic function. So the identity is hyperbolic cos square alpha minus hyperbolic sin square alpha equal to 1. Now by this identity, if I shift this hyperbolic sin square alpha on the RHS, then this 1 will come here, that will become negative 1. So we'll get, and if I want the value of hyperbolic sin of alpha, then I will take square root on both sides. So we'll get hyperbolic sin of alpha as under root hyperbolic cos square alpha minus 1. Now guys, what is the value of hyperbolic cos of alpha? So here we got the value of hyperbolic cos of alpha as A. So I'll put this value of A over there. So we'll get under root A square minus 1. So this is the value of hyperbolic sin of alpha. So guys, in this result I can put that value over here. Now we just want the value of hyperbolic sine beta. So to get that value, I'll do the same process. So again, by this identity, we can say that the value of hyperbolic sine of beta is under root hyperbolic cos square beta minus 1, and we have value of hyperbolic cos beta, which is b, so that will become b square minus 1. Now similarly, we'll find out the value of hyperbolic sine of gamma, which is under root hyperbolic cos square gamma minus 1. Now for hyperbolic cos gamma, we have the value which is x, so we'll get under root x square minus 1. Now guys, the value of hyperbolic sine alpha, hyperbolic sine beta and hyperbolic sine gamma is under root a square minus 1, under root b square minus 1 and under root x square minus 1 respectively, and we'll substitute these three values in the previous result. So here I'll put those values. So we'll get value of hyperbolic sine alpha, which is under root a square minus 1. So here I'll write under root a square minus 1 for hyperbolic sine alpha. Now what is value of hyperbolic cos beta? So it is b, so into b, plus value of hyperbolic cos alpha, which is a, so a, and the value of hyperbolic sine beta, which is under root b square minus 1. Similarly, value of hyperbolic sine gamma, which we got there, which is under root x square minus 1. And now guys, if you will see, then this is what the result that is given in the question. So here we have proved the result, and I'm sure you understood the explanation. So guys, just keep watching the videos and don't forget to share this video with your friends and subscribe to this channel, because then only you'll be able to get the latest updates and the new videos of Ekeeda. Thank you very much.